Hey there everybody, Mr. Murray here again. Let's continue on with a little vertex form practice. See if we can get a little further with this. Hope everything is going well and trying to be normal here just so you know I'm still wearing a tie every day. Here it is, just to prove to you. Nice math tie there. Okay, let's get cracking on this. Part A here. We're going to give the vertex of each parabola. Remember, this summarizes what we went over on Friday. The vertex, I haven't added or subtracted anything to the inside, so it hasn't moved horizontally at all, so it's 0, and plus 3 on the end means it moves up 3, 0, 3. This one right here, subtract 6 on the inside. Well, that means, again, we're looking for the x value that makes it 0 on the inside, so that would be positive 6, the opposite of negative 6. And you see positive 2 on the end, moves up 2, so 6, 2. This one right here, minus 3 on the inside, minus 7 on the end. That's going to move to positive 3, negative 7. 3 units to the right, 7 units down. The 5 out in front doesn't affect the vertex, just the direction of the opening. It's positive, so it would be opening up, and it's bigger than 1, so it would be a vertical stretch. It would be a skinnier version of a parabola. But right now we're just talking vertex, and so this one right here, plus 10 on the inside, moves to the left 10 units, minus 3 on the end, moves down 3. Okay, so we just saw a few examples. Now let's actually graph them and answer some questions about domain and range and all that good stuff, just to review all that. So first, you see it in this form. Let's think about that vertex. It's vertex form, so that's the easiest thing to get right off the bat. That vertex is going to be at negative 3, positive 5, right? Plus 3 on the inside, and plus 5 on the end means 3 units to the left and 5 units up. So if you remember from doing our tables here, because of the symmetry of a parabola, we always want to use the vertex as the middle of the table here. So negative 3, 5, that's the middle of the graph, so it's going to be the middle of my table. I'm going to do a couple values to the right and a couple values to the left. Now if you're plugging them into this, you can use your calculator again, just use parentheses carefully. If you're trying to give your brain a little bit of workout, just use a little order operations. It's pretty easy actually. Start on the inside, negative 2 plus 3, that's 1. Then you do the exponent. So 1 squared is 1. Then you multiply by negative 2. 1 times negative 2 is negative 2, and negative 2 plus 5 is 3. Negative 1, when I plug that in, negative 1 on the inside plus 3 squared plus 5. Negative 1 plus 3 is 2. 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. And on this side, if you trust yourself, you know that these are going to be symmetric. So if this was 3, this is 3. If this is negative 3, this is going to be negative 3 because I'm the same distance away from that vertex. But you could check and just to make sure, because if you don't get the same y value, maybe your vertex was a little messed up. So let's draw this graph here. Negative 3, positive 5. So negative 3, positive 5. There, negative 2, positive 3, and negative 4, positive 3. Negative 1, negative 3. Negative 5, negative 3. And then we'll do our best to draw this parabola. Remember, the graph doesn't stop. Just go right to the edge of the graph, trying to continue down in that same fashion there. All right, so we have that, and now the axis of symmetry. Axis of symmetry, remember, is this imaginary line. You don't have to draw it, but it goes right down the middle, right through that vertex. That vertex is at negative 3, 5, so it's at x equals negative 3. I mean, this is the x value, so just take a look at that. It's always the same as that. The direction of the opening, well, clearly you can see it's down, but you probably should have known that right from the equation because that a value is negative. Is this a stretch, compression, or neither of the basic parent function, as they call it, of y equals x squared? and you're looking at that 2 to determine that. 2 is greater than 1, that's a greater rate of change, which results in a stretch. It's a skinnier version. It looks like somebody is stretching it, whereas a wider one looks like somebody is compressing it. The domain, all real numbers for all parabolas, and the range of this parabola, 5 is that greatest y value, so all the y values are less than or equal to 5, looking at the y coordinate of that vertex there. And the last question, we kind of already said it, the max value is 5. You're referring to the y value. Okay, let's just take a look at the back, and you're off and running. The back here, you don't have to draw the graph to answer these things. It's just, can you answer them all without doing too much work? Looking at this, what's the vertex? +4 on the inside, +5 on the end. So that's going to be -4, +5 for your vertex. The axis of symmetry, hey, if you know the vertex, you know the axis of symmetry is a vertical line, so x equals whatever that x coordinate of the vertex is. It goes right through that point. Has there been a reflection over the x-axis? And when we ask that, they're really just asking, is it opening up the normal way, or has it been flipped upside down? And this a value tells you about that. It's positive, so that means there has been no reflection over the x-axis. It's opening up. Translation is just another word, we've used it here and there, but it's another word that means sliding the graph. Where has it been slid compared to 0, 0, where the vertex normally is? Well, it's been slid to -4, 5. So that would be 4 to the left and 5 up. Basically asking the same thing as this vertex, just kind of using words to describe it. Has there been a vertical stretch or compression, or neither? And in this case, you're looking at that a value again, not whether it's positive or negative, but the fact that it is less than 1/2, that would be a smaller slope as compared to the normal, so that would be wider, or a compression, right? It would look kind of squashed, taking the normal one and be a little wider. The domain, don't even need to think, it's all real numbers. The range, talking about those y values, this is the y coordinate of the vertex. Is that the lowest or is it the highest value? And that's really, think about whether this graph is opening up or down. You know it's opening up because that a value is positive, so that vertex is the lowest point, so all the y values are greater than or equal to 5. Okay, hope this helped. Just brush up on a lot of little ideas put together. Try the homework, and as always, ask questions if you have any. Good luck, kids.